For today's video, we will answer a geometry challenge given by one of our followers. And the question goes like this. Given this circle, let's draw some radius and let's call this angle be equal to y degrees. Now let's draw some segment and let's call this angle be equal to 75 degrees. Another set of segments, let's call this angle be equal to x degrees. Now our goal is of course to find the value of x and to find the value of y. Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you get the correct answer. Alright, now given this information, this 75 degrees, our goal is to find the value of x degrees and this y degrees. Alright, so to answer this question, of course, let's name some important points. Let's call the center be equal to O. So center O, this circle O. Let's call this point be equal to point A. This point is point B, and this point is point C, and the last point, we call this point D. Now, let's use this concept to answer this question. The first concept is the supplementary angles. Supplementary angles are two angles that adds up to 180 degrees. They can be adjacent or not adjacent, like in this picture. Now, using this concept, if this is 75 degrees, this other angle, this is supplement of 75 degrees. Therefore, these two angles adds up to 180 degrees. It follows that this angle right over here must be equal to 105 degrees because 105 plus 75 degrees will give us 180 degrees. Alright, and how about this angle? If this angle is x, then the other angle must be equal to 180 minus x. Because if we add 180 minus x plus x degrees, this will add up to 180 degrees. Now, another concept to answer this question is what we call the inscribed angle theorem. So, the inscribed angle theorem states that the measure of an inscribed angle is half the measure of its intercepted arc. Alright, now using this, if this is the inscribed angle 105, therefore we can say that this arc ABC, must be equal to twice of 105 or simply equal to 210 degrees. So arc ABC must be equal to 210 degrees. Now another concept is the whole circle must be equal to 360 degrees. It follows this arc ADC must be equal to 150 degrees because 210 plus 150 degrees, this will add up to 360 degrees. Alright, now we are now ready to solve for the value of x. So let's get the information that we want. This angle ABC, which is 180 minus x degrees, and this arc ADC, which is 150 degrees. Now, using the inscribed angle theorem, we can say that this angle right over here, 180 degrees minus x degrees, must be half of this 150 degrees. This is according to inscribed angle theorem. Now, we can also solve for the value of x because 150 divided by 2, this is just 75 degrees. Now, let's solve for the value of x. Let's subtract 180 on both sides. Then 75 degrees minus 180 degrees, this will give us negative 105 degrees. And if we divide both sides by negative 1, we get that x degree must be equal to 105 degrees. And there you go. We have the value of x. Now, how about the value of y degrees? Alright, the last concept that we need is the central angle theorem. Now, it says that the measure of the center angle is equal to the measure of its intercepted arc. So, given this concept, let's have the measure that we want in this picture and solve for the value of y degrees, of course. So, let's have this angle AOC, which is the y degree, and this arc ADC, which measures 150 degrees. Now, using the central angle theorem, we can say directly that y degrees must be equal to 150 degrees. And there you go. We have the value of x degrees and y degrees. X degrees equals 105 degrees and y degrees equals 150 degrees. And as always, we are done.